All right, guys. Continuity recap, chapter 2.3. What do you need to know? First thing you need to know is definition of continuity. You have three requirements. First of all, the limit as you approach the point that you're interested in from the left, and the limit of the point you're interested in as you approach from the right must be equal, and they must both equal the value of the function at that point. Another way to write this is that the limit as x approaches that point is equal to the value of the point, because of course the limit does not exist unless both this is true and this is true. So there's your definition of continuity. The limit exists and it is equal to the value at that point. Types of discontinuities, you can have a removable, which of course is just a hole. We recognize a removable discontinuity usually if we're looking at polynomials, for example. If I see x minus 3 over x minus 3, I know that this implies that there's a removable discontinuity at x equals 3. There is a jump discontinuity where a function just jumps. And there is an infinite discontinuity. And another, if we're thinking about algebraically, if I saw 1 over x minus 3 in an equation, I would know that there was an asymptote, a vertical asymptote at x equals 3. So that's pretty important concepts right there. How do you fill these discontinuities? Well, if it's removable, you just add a point. Add a point in the appropriate place. If it's a jump discontinuity, you just shift one of the functions up or down. And if it's an infinite, there's nothing you can do about that. Okay, intermediate value theorem. Intermediate value theorem says that if you have some lower bound of a continuous function and an upper bound of a continuous function, every value in between must appear on the function. So we have the closed interval AB, and we have a continuous function that if y sub 0 is between those two output values or y values, then y sub 0 equals f of c, where f of c is in between a and b. All right, guys, there it is.